So next up, we have geographer Benjamin, and he's going to tell us a little bit about his project, Worldmapper. Let's give him a big hand.
Thank you very much, Brian. Thanks for having me here today. Yeah, I'm a geographer, and when I went to university and learned geography, cartography was part of the learning process. But I guess any trained cartographer would be saying, like, no, you're not a real cartographer, you haven't learned it properly. But I happen to be, and that's what I think you put in my CV as well from my website probably, I'm an accidental cartographer. So I spend most of my life these days making maps. And there we are. I want to show you the world as you've probably never seen it before, unless you've come across the project that I'm going to speak about today. And since I tend to always run out of time at the end, I thought I'd just put the credits on the first slide. The project I'm presenting here is called Worldmapper, and obviously it's not my own project, but there's a huge amount of people who have been involved in the project over the years. We first launched it at the University of Sheffield in 2006, and by now the project is mostly being maintained and developed by myself and Tina, but you see the list of people who have been helping in this project over the years, ever since it was launched in Sheffield at the time. So let me start the whole presentation and explaining you the story of Worldmapper with a message I got a while ago on Facebook. Sent by someone called Jonathan. I put his surname out for privacy reasons, and he said, "Hi Benjamin, have you heard of the flat earth movement? If not, I would love to hear your views on it. The earth is flat and the ball has been a lie. And grant deception, if you will." Well, obviously I've heard about these people before, so I was wondering, like, why does he bother contacting me? But he got very excited, basically saying, like, "It excites me to know that you are a geographer, not a cartographer, with an open mind. The flat earth movement has many passionate people involved, but I have yet to come across anyone skilled with maps. Having insights such as yours on the flat earth map would be incredibly useful. The map for flat earth is based on the idea that anywhere you are in the world, if you travel south, you will hit Antarctica." Now, I don't want to go really into detail of what he is proposing here. I think we've all heard about the flat earth movement. But I have to say, in one aspect, he's right. If we look at the maps that we are using these days, they are, to some extent, a great lie. And let me start that with another story. It's probably an urban myth, but here we go. It was reported even in the Washington Post in 2004 that there was a mayor in a town in Italy who wanted to forbid these spherical goldfish bowls that you see here on the right-hand side of the picture. Because what he says, and if you ever put a goldfish bowl on above your head, you will probably notice everything gets a bit squeezed and distorted because of the sphere of the glass. And his argument was that the goldfish who are swimming in these bowls, they are suffering because they are seeing a distorted world. So he wanted to forbid these goldfish bowls and instead have normal fish tanks. Whether this is any better solution for the goldfish, I don't know, but again, it's not the main point here. The main point is, what view of reality do we have? And that brings me back to maps and to Jonathan. This is one of the kind of maps that we use on a daily basis. If you open your phone and zoom out, you probably see something like this, which is called the Mercator projection, which was invented in the 16th century by someone called Mercator, a cartographer, amongst all things. The problem with this projection obviously is, and I think you've probably heard this before, it distorts the planet quite a lot. Actually, if we really extend this projection here to its real extent, it would be an endless map, because the way of how this is constructed geometrically basically leads to the fact that basically the closer we come towards the polar regions, the more and more distorted the areas get, which basically brings us to the effect that Greenland, for example, here looks like being bigger than Africa, which in reality, obviously, it isn't. But on the other hand, from an Icelandic perspective, Iceland gets a bit bigger space in here than it should be having on a map. On the other hand, Mercator has been condemned a little bit too much because it's a quite useful geometric tool that helps us navigating the planet. This is why Google and their likes are using it. It's mathematically and for algorithms that help us to calculate directions and distances, etc. It's quite useful. It's quite practical. On the other hand, it seems a bit unfair because basically it's an over-representation of the spaces which are in the polar regions or coming closer to the polar regions. So especially the northern hemisphere gets quite a lot of credit on these maps, which it shouldn't be getting. And thinking back to the Cold War, countries like the US or Russia look a lot bigger than they should be. So there are other solutions for that, and a guy called Peters picked up on an idea of somebody else 100 years earlier, Gall, who are using a cylindric equal area projection, and even the ancient Greeks already knew about this, to produce a map like this one here, which should be fairer because basically it gives every country the same amount of space, or the correct amount of space. On the other hand, as you can see, if we look at Iceland again, Iceland looks a little bit more like a flat pancake. So it's distorting as well. It's distorting how the countries really look, where Mercator is actually a lot better. And yet, there's still a problem with these types of maps. I could go on and on and on. There's dozens, there's myriads, hundreds, thousands of different types of map projections, but they're all sacrificing some of the reality that we're looking at because we have to make compromises when we try to put the sphere onto a flat surface. And there's another problem. This is a visualization of population density. And as you can see, you hardly see anything. Most of this space in here is black, which lies in the fact that about 95% of us, of the world's population, live in about 10% of the area. So a lot of the space that we're showing in maps actually is wasted space because this is where people don't live. And if we want to understand the planet in an age of globalization, in an age of humankind, we sometimes might need to change our perspective because if we try to look at the world with normal maps, we don't really see the realities that we're living in. This is where statistics comes in. Statistics invented quite useful things like charts, for example, a pie chart, which, as you can see, is probably also not the best way of understanding these numbers in a most appropriate way. So if we were to draw a pie chart of all the countries in the world and their population distribution, it wouldn't be more useful than this map here. Probably it would be even less useful. The only thing that this pie chart tells us is China and India are big, and the rest is comparatively small. And also it loses the advantage of a geographic visualization. So let's go back to maps and think, is there not another way of showing these numbers in a better geographic way? Obviously, because I'm asking, there is another way. And this is what cartographers and geographers call cartograms. If we bring the idea of a pie chart together with the idea of a map, then we actually come to something that basically shows quantitative numbers in cartographic form. If you put your eye on this planet now, the colors show you the different altitudes. So the green areas are the low-lying areas, the brownish areas are the highest-lying areas, like the Himalayas, you can see, or the Andes in South America. What would happen if we try to show where people live instead of where sheep live, or where no one lives, where there's nothing? This is what happens when we try to look at it from a cartogram perspective. Now look at your favorite place on the planet and see how it changes when we try to look at the world from a population perspective. What is happening here is and we're coming back to a grid square. We've seen that before. There's no hexagons in here, but at least we've got the raster cells. If we split the land area into equally sized grid cells and then apply the number of people living in these areas to it and then distort each of the grid cells according to the number of people living there, this is what is happening. So heavily densely populated areas get bigger and unpopulated areas get relatively small or almost disappear. As you can see, if you look at Northern Africa, Sahara Desert, for example, disappears. It's like these converging grid lines basically giving space for humanity instead of giving space for the unpopulated areas. Why is this useful? First of all, obviously, it gives space for people. And here is an example of how this could be working for a much more valuable geographic depiction. This is a picture you've seen before, Earth at night. It's a composite satellite image from NASA. It basically shows the brightest spots on the planet. And usually we tend to think the areas where people live are the bright areas in this depiction here. But if we apply a population cartogram technique to it, this is what we get. Now we see an equal amount of people in each area, and we suddenly start seeing, if we go to the African continent, for example, you see now these very bright grid lines, but we see a lot of space here that is unpopulated. This is where Cairo is, for example. Up here, this is Moscow. We've got the Pearl River Delta in southern China here. And then if you look at Central Europe, for example, we see a much more even distribution of light when it comes to the correlation with people. So we start seeing actually inequalities, global inequalities in access, for example, to electricity. We also see the wasteful lives that we live in Central Europe or in North America, because basically there we've got quite a lot of light pollution. But what we see as well is that by far the picture we saw before doesn't give us an idea of population distribution across the planet, because quite a few people on this planet are living without access to light or electricity. But what about these areas where no people live? So we've got here the areas that are most heavily densely populated, but we could also do the opposite game and see like what are the most distant remote places that are furthest away from people. We can apply a cartogram projection on that as well if we do and tweak the numbers right. And this is what we get when we look at distance from the nearest population centers if we travel over land. So there's a little bit of complicated math behind there to calculate these spaces, but basically what this shows are the remotest places that are furthest away from the biggest cities in the world. So Greenland and obviously Tibet, for example, are standing out in the Himalayas, whereas the most heavily densely populated areas in Central Europe, for example, they become quite small because obviously there's relatively few remote areas. But even here we can see northern Britain, so Scotland, for example, being relatively bigger than the south. And we could zoom into these maps and start seeing these details. And so once you start getting used to this kind of visualization of data, you can really go crazy and take anything that we can count on this planet and just do similar transformations, such as rainfall distribution, for example, throughout the year. So what we're seeing here is month by month over a 40-year average, seeing where how the rainfall patterns are distributed. So we see the effect of the monsoon rains in the late summer. We see Asia getting bigger. We see like this meandering tropical area throughout the year. Or we can take it even further and look at satellite observations from the productivity of nature, which looks like a heartbeat of nature. Always applying the same principle, the most productive areas are the biggest, and if you look at it at an annual cycle, we start seeing like how Earth is breathing in terms of bioproductivity. So it's a quite powerful way of visualizing this quantitative information, and if you look at images like this one here, there's millions of individual data points in here, which just make these numbers a lot more accessible than if you were to look at complicated graphs or techniques. And this is a little bit of the idea of what we're trying with Worldmapper, in most cases in a much more simplified way. So the project really started as a collection of world maps or cartograms that try to visualize basically this growing amount of data that agencies such as the United Nations, the World Bank, and etc. started compiling and releasing online about 15, 20 years ago. And later on, we moved into much more complex visualizations that are utilizing, for example, satellite observations. But if you take it back one step further to the beginnings, basically what we need is a world map that we can distort. And we developed a color scheme. This comes from our most recent release. We developed a color scheme that helps us orienting in these distorted maps. Because obviously, if you don't see them every day, you need to learn how to read them. So what you see here is basically the United Nations regions that we colored in through different colors, so that the colors, once we start distorting the maps, help us to read which areas we are in the world. And then we vary the hues and lightness just to have a bit of differentiation within these different regions. And actually, this new color scheme was inspired by Iceland. We took out the spectrum from Northern Lights colors that we applied to the different regions, as you can see down there. And once you get accustomed and used to these colors, actually you can start really reading and focusing on the actual data distribution. So if instead of taking a grid, we, for example, resize the different countries of the world, so not within countries, but the different countries, we get a much more accessible visualization because the country shapes are still saying the same, such as here in the population distribution. This would be the equivalent to the pie chart I've shown you before, and you can judge yourself whether you think the pie chart is more useful or whether this cartographic representation is more useful because it helps us to orient ourselves with our geographic knowledge that we bring. And we can go, obviously, we can go crazy because there's thousands of different data sources available that help us to visualize this information at a national level, such as alcohol consumption, for example, distribution of McDonald's restaurants in the world, or nuclear weapons. Anything that you can count can be turned into cartogram representations. There's a little bit of tweaking the data if you've got data gaps, etc. So it's a quite painful process, but the actual outcomes are quite powerful visual representations. And I was looking for one, because we are in Iceland, I was looking for one that makes Iceland a bit bigger as well. So I took volcanic eruptions in the past 15 years, and we start seeing Iceland becoming a bit bigger. It's actually quite imminent, so if you're lucky or unlucky, we'll see. We'll get an eruption in the next couple of days, and you might not be able to fly back. But you got a little bit of the idea of how cartograms work. They are basically a quite helpful tool to make the large amounts of data accessible, available, understandable in a much more intriguing way. And that's what I want to just focus on in the last few slides to make the twist towards the conference here, the web as material. Cartography, cartographic depictions, maps ultimately are something tangible, something on paper, at least historically. But obviously, we're seeing quite a big change in terms of data availability, which is basically what Worldmapper quite heavily utilizes and relies on. So this whole revolution of what probably nowadays we would call big data, etc., basically was the real start of what Worldmapper tries to do. It tries to make these huge amounts of geographic information accessible and understandable. And secondly, the web actually has a quite good chance of approaching how to present this information in a different way than we do it traditionally with cartographic depictions. So normally we would just make an atlas, you open it, and you basically just explore the information in the atlas. Whereas if you put an atlas into a digital environment, you are a lot more flexible into how you can curate this atlas. So earlier this year, we launched the new Worldmapper website. The old one looked a little bit outdated. It was created at university by university people, and that's how it looked. But this year, we got some people from Human Studio in Sheffield on board who helped us creating the website, how we wanted to do it, and how we wanted to turn it into a real digital atlas. So this is the front page. As you can see, we always put the latest information and the latest maps onto the front page. But what is the really powerful part of this digital atlas as compared to a printed atlas is the flexibility that we have, for example, through navigating through a series of topics, through linking different maps with each other. So to make this content, and we are growing, you can see there's over 500 maps online by now, to make it accessible and to get an overview of this information, to access it in terms of what you are interested in, but also to give you inspiration of what else you might find interesting, or to give you this little extra element of discovery and exploration. So when you go to the map section, you always see the latest ones, but then you've got the possibility to go into the different themes that we created here and then divide them into sub-themes and really get to the information that you might be looking for. And what we can do as well in an online atlas, we can add up-to-date further contexts. So we added a blog where we put these maps into further context and try to explain these maps or put these together into little geographic stories. So the web is a real advantage here because suddenly it makes the curation of map collections accessible in a much more different way than we would be able to do it in an offline environment, including the search function and all of these different elements that we can integrate here, including magnifying glasses to see the maps in a better way, so you can zoom into different areas and all of these different aspects that would just not be possible offline. And as said before, we're also benefiting highly from the digital data availability to realize this project and to keep it going. So let's end with Jonathan, who was quite persistent and kept writing me. So a couple of months later, he was sending me another email. Hey, Ben, it's been a while. Hope you're well. I'm calling in you at this time because it seems that there is a problem in the flat Earth communities. Well, there is, but basically what you can read here is he was hoping that I could help them making a better cartographic depiction of their ideas. There, actually, I have to disappoint Jonathan, even if his idea that we're looking at the world in the wrong way has something about it, I really can't help them to make the flat Earth depiction quite the opposite. What we try to do in Worldmapper as well, we've teamed up with a company called Pufferfish to bring cartograms back onto the sphere. This is a project that hasn't seen the light of day yet, but we are currently exploring ways of basically bringing the map back onto the globe in a digital way and make cartograms accessible in a much more intuitive way of how we have learned to read maps or how we have learned to actually understand the planet. And basically working with this surprise effect of the world not looking the way it should be looking, as you can see here, but on the other hand, still having this familiarity with the globe that we have become used to and accustomed to. And you can see basically these interactive displays that they are building also allow us to interact with the content, to also, we started exploring also possibilities to add basically additional context by tapping on countries, etc. So it makes it even more vividly accessible of how we can explore these quite unusual forms of geographic data representation. And with this example and little outlook into the future of what Worldmapper might still have on board for the future, I want to just basically thank you for your attention and encourage you to go to our website and look at some of the examples you find there. And if you have any ideas or any suggestions of what we could do differently, we are always open for your suggestions. You find us in all the different social media platforms, etc. So thanks for your attention, and I'm looking forward to quite a few more interesting presentations today and see how this all links to what we are doing here. Thanks.
Thank you very much, Ben.